Hello. Good afternoon, everybody. Welcome again. Welcome to Mouth with Isaiah. I'm actually excited to be here. Welcome. Apologies. I believe I'm 6 to 7 minutes late. Yeah, 6 to 7 minutes late. Apologies for that. Yeah. So let's just get. So I was actually in a bit of, would I call it indecision? I wanted us to touch coordinate geometry, speaking about gradient, midpoints, equation of a straight line. Yeah, those, but that would be broad for us to do under 30 minutes. So I decided, okay, I'm going to cover SURDS today. Then I want to really try to make a video about all of this. I might do it in beats, explaining each of them. I might explain how to solve for the gradient of a straight line, how to solve for the equation of a line, how to get your coordinates. So I think I'll break it into bits, post it on my channel, so you can all go back and watch it at your convenience. Yeah, I think I'll do that. So today we'll be looking at SURDS. Today is day 12. Day 12, and we'll be looking at SURDS. Yeah, SURDS. So that's what I'm going to do. So tomorrow, which will be day 13, we'll touch differentiation, calculus, all of those things tomorrow. That thing is actually simple. It's just like I don't know if I've said it here before, but when you begin to get into undergraduate mathematics, let's say like in university for instance, like 200 level mathematics, then you begin to hear something like higher order derivatives, partial derivatives, yeah, things like that. It begins to get a little broad and a little different. Well, let's attend to what we're going to attend to. So today we're looking at SURDS. SURDS has to do with roots and improper equations. Alright. Very quick one. I don't want to take so much time today, so for example, hey, let's look at this. The square root of 45. Now this is what SURDS look like. So the square root of 45, for instance. Now you would agree with me that this simply means we have to look for the square root, right? If you had, for instance, the square root of 81, we know it to be 9, right? But now what is the square root of 45? It will definitely give you decimal numbers. It will give you decimal numbers, right? So now SURDS now tells us that we can simplify numbers like this. That's what SURD is all about. Simplifying numbers like this. Now, for instance, look at this. Let's do it in such a way that we have one perfect square here and another random number. For instance, the square root of 9 times 5. What's 9 times 5? It's still 45, right? 9 times 5 gives you 45. Now, this has a square root, right? The square root of 9 is 3. Now, imagine we do something like this, the square root of this. Now, mind you, this is the same thing as the square root of 9 and the square root of 5, right? Now, the square root of 9 is 3. So we can call this 3 root 5. Now, this is what simplification of SURDS basically means. So it tells you that a big number like this can be broken down into this, then this, then this. Let me find a few other examples. Let's quickly do this. Okay, square root of 3 roots 50. We have 3 roots 50. Now, let's quickly solve this. 3 is on the outside, has no root ahead of on top of it, so it's good. Now, let's break this down. 3 square root of, let's break this 50 down to one number that we can find the square root of it and another random number. That's 25, right? 25 times 2. Now, this is the same thing as, I don't like long journey. So, what's the square root of 5? Of 25 rather, that's 5. Now that 5, you go multiplying it by this. So 5 times 3, you'll be having 15. We can't find the square root of 2, so it stays there. Right? Now that's another one. Let's simply do this one. See. Square root of 162. How do we break this down for two numbers? You can find the square root of 1, the other can just be a regular random number. This will be what? 81 times 2. Now what's the square root of 81? 9, right? So the answer to this is 9 root 2. So this is what SURD is talking about. Talking about simplifying numbers like this into something like this. I'm very sure that's very easy to understand. So let me solve a few more examples. Now, there's another side of it. Expressing numbers like this as a whole SURD. For instance, there's an example here, or a question rather. How do I do this? Okay, the question is this: express each of the following as a square root of a single number, as the square root of a single number. Number 1, 2 root 3. Now this is 2 root 3, right? Now how do you solve something like this? Basically what you're going to do is, we want to bring everything under one root. So you have to multiply this by itself, then I multiply it by this. That's my own principle to it. But what they will tell you in textbooks is to find the number that you found the square root of to get this. That's 4, right? So you'll be having something like this: the square root of 4 times the square root of 3. 4 times 3, this becomes square root of 4 times 3, which is square root of 12. That's how they will tell you to solve this in textbook. But I just tell you this times this times this. 2 times 2 is 4, times 3 gives you 12. Just put everything under one umbrella, live and direct. Now, if you wanted to break this back to this, you find it, you break it down to two numbers, right? One number that you can find the square root of it, the other can be any random number. That will be 4 times 3, right? Then you now find the square root of 4, which brings you back to 2 root 3. So this tells you how to reduce it to this. This tells you how to bring it back to this. So let's do one more example. B, 3 root 2. Now, using textbook method, what's that number that you found the square root of to get this? That's 9, right? 9 times square root of 2, which is what? Square root of 18, right? What's my own? 3 times 3 times this. And you're good. Straight to here. You don't have to write any jargon whatever. Now, okay, so let's do this. Now let's do addition. Let's do addition. Alright, so we have number 1, 4 root 2 plus 6 root 2. Now 4 root 2 plus 6 root 2. Now how do you add something like this? Now there are laws when you have to do with multiplications, and there are laws when you have to do with addition and subtraction. Now this, for instance, you use that method of factorization. They have something in common here, which is what? Root 2. Root 2 is here, root 2 is here. Then you open the bracket, 4 plus 6, that's 10. So the answer to this is 10 root 2. But I don't like stress. I've always told you that before. Square root 4 root 2, 4 root 2. As long as they have the same root here, you can add whatever is behind them together. So just add it. 4 plus 6 gives you direct 10 root 2. But if you have 4 root 3 and 6 root 2, then you cannot add it. You can't go on from there. That's the end of the equation. The end of the expression rather. You cannot go on from there. But once they have the same root, then you can add whatever is behind them straight up. Now that's one principle I have to tell you. Okay, 3 root 5 minus 7 root 5. 3 root 5 minus 7 root 5. They have the same root. 3 minus 7 gives you what? Minus 4 root 5. Simple as ABC. 3 minus 7 minus 4. Put your root 5 there. You're good to go. That's how you solve something like this. The same thing here. 4 plus 6. That's 10 root 2. Straight up. Now, I'm going to call one question. Okay, now look at this. 3 root 8 plus root 50. The square root here is 50, the square root here is 8. Can you add them together? No. But you can break this down. We broke 50 down here. What are the two numbers? 25 and 2, right? So what's the square root of 25? 5. You can't find the square root of 2. Automatically that tells you this is 5 root 2. Now I'm doing it live here so you can see that you don't really have to write all the time. This is 5 root 2, right? Now what are the two numbers here? 4 times 2, right? Square root of 4 is what? 2. That tells you this is 2 root 2. 3 into bracket 2 root 2, right? 3 times 2 gives you 6. 6 root 2 plus 5 root 2. Can you add them together? They have the same root. Yes, 6 plus 5 is what? 11 root 2. That's how you solve these kind of things very fast. Let's go over it again. 3 root 8 plus root 50. Root 8. What are the two numbers? 4 and 2. What's the square root of 4? That's 2. So that tells you this is 2 root 2, right? Then multiply by the 3 that is here. 3 times 6 gives you 6 root 2. 6 root 2. Now we are here to 50. What are the two numbers? 25 and 2. What's the square root of 25? 5. That stands outside. Then root 2. Then you add 6 root 2 plus 5 root 2. 11 root 2. As simple as. So that's how you attend to questions like that. Give me 1 second. Alright, so welcome back. Sorry about that. Did I just say welcome back? Alright, let me clean this up and let's quickly finish this. So that's SURDS. SURDS is actually basic. It always comes out in your external examinations most of the time. Most of the time. There are a couple of topics that do come out in all those external examinations. Indices is there. That's why I'm trying to cover them. Indices is there. Logarithm is always there. Simplification, okay, approximation, sometimes simple interest, all other topics, mensuration, others plane shapes, all those things. What other topics? What other topics? What other topics? Couple topics like that comes out. Trigonometry comes out. Sometimes polynomials. Sometimes polynomials. There's what do they call this thing? Binary numbers. All forms of simplification comes out basically. So yeah, let me not waste so much time. Let's go into a few more questions. Alright. Alright, so now let's do this. Let's do multiplication now. So this is multiplication. The way you do addition is the same way you do subtraction. There's no difference. But multiplication and division is a little different. So this question now. Square root of 27 times the square root of 50. What do we have? Square root of 27 times square root of 50. Let's break this down. What does that give you? 9 and 3, right? Square root of 9 is what? 3. That tells you 3 root 3. I like you being fast. Times, what's the number? 25 and 2, right? Square root of 25 is what? 5. That tells you 5 root 2. Now, when you are dealing with multiplication, you can multiply. You have to multiply what is outside and what is outside, and then what is under the root and what is under the root. So 3 times 5 gives you 15. This times this, 3 times 2 gives you 6. So this is the answer to this. That's for multiplication. Let's quickly do one more example. Just one more. Just one more. Quickly look at this. 2 root 5 all raised to the power 2. What does this mean? It means this times this, right? So this is the same thing as 2 root 5 times 2 root 5. What does that mean? 2 times 2 is what? 4. Now, Let me just give you a very straight up answer. Whenever you're multiplying same root together, it becomes only, you eliminate the root. Let me explain. 5 times 5 is what? 25. Then what is the square root of 25? It boils down to 5. So automatically the root is eliminated. So you have 4 times 5 here, which is 20. So this is how you solve something like this. Keep that in mind. I want to quickly do division. Division has to do with rationalizing. They call it rationalizing numbers. So division quickly. Now rationalize the denominators of the following. This is 6 over root 3, for instance. Now, when you want to rationalize, you multiply the numerator with the denominator, and you multiply the denominator with the denominator. That was tongue twisted. So this is what I mean. Times root 3 over root 3. You use this base to multiply all of them. Now, this will be what? 6 root 3 over what? When you have the same thing and you multiply it, the root is eliminated. This becomes 3. 3 here 1, 3 here 2. This gives you what? 2 root 3. This is how you divide or rationalize. That's what they call it. Rationalize. So this is rationalize. Let's do a few more examples. Let's do 7 over root 18. Now let's break this down. Root 18 is going to be what? What are the two numbers? 9 times 2, right? Square root of 9 is what? 3. That's 3 root 2. Then now let's multiply the numerator and the denominator. But this time around, you will not be multiplying with 3. It's just the root. Times root 2 over root 2. So that's how you attend to something like this. Now this times this gives you what? 7 root 2. This times this gives you what? 3. Root 2 times root 2 is what? 2. Then 3 times 2. That's what? 7 root 2 over 6. So this is the answer to this. Let me see if I can try one more example. Now quickly look at this. 5 over root 5. You already know how to solve it, right? Times root 5 over root 5. That's 5 root 5. Sorry. That's 5 root 5. 5 times root 5. That's 5 root 5. Root 5 times root 5 is what? 5. And this will cancel out this, which gives you what? Root 5. So this is the answer to this. So that's how quickly you solve all this kind of questions. I'm doing them very quickly so you know that they are not so hard to solve. Now look at this. This is the last one I'm going to be doing. Root 16 over 7. How do you solve something like this, for instance? How do you solve something like this? Okay, there's still a few other topics, few other sides of it I might be wanting to touch. Now, square root of 16 over 7. Square root of 16 is what? 4 over root 7. Right? Then you multiply as always times root 7 over root 7. The answer is what? 4 root 7 over 7. So this is how you solve something like this. Very quickly and straight to the point. When you're multiplying, you multiply individually. When you're adding, you make sure that they have the same root before you can add. If they don't have the same root, you stop there. When you're dividing, you're rationalizing, you're multiplying both the numerator and the denominator with the denominator. That's how you rationalize. Now, I would have gone to expanding, but I don't think I need to do that anymore. So, alright, I want to quickly look for one example. This is going to be a long one. This is going to be a really long one. Whew. It's going to be a long one. Alright, let's do this. Let's do 2 over, I'll just do one example of this and I'll try to be very explanatory. 3 root 5 plus 4. Now give me a second. Apologies for that. Okay, so now look up. So we have 2 over this. Now, whenever they say this one now you have to rationalize because this is also division. But these two are together. So how exactly do you rationalize something like this? Now look up. Now, this is going to be this, let's move this, times, you're rationalizing with this base. But once you want to rationalize with a base like this number inside changes to negative. So if you're having something like this, times 3 root 5 plus 4 over 3, sorry, minus 4 rather. It changes to minus over 3 root 5 minus 4. So now you have to multiply this times this times this. What do you have? 2 times 3 is 6 root 5. 2 times minus 4 is what? Minus 8. All over this times this. This is difference of 2 squares. So there's no point multiplying this times this times this times this. No. This difference of 2 squares, I'll explain that later. Let me just explain it. When you have something like this, a squared minus b squared. This is difference of 2 squares. Difference, it means the negative sign. 2 squares means they both have squares. So the answer to this is a minus b, a plus b. This is a very standard way to express this. A minus b, a plus b. Now, let's expand this. A times a squared. A times ab plus ab. This times this minus ab. This times this minus b squared. They will still cancel out. At the end, you'll be having your a squared minus b squared. That's why it is called difference of 2 squares. So you just pick the both of them, open a bracket, put the minus, open another bracket, put plus, and that's all. Now, if you look here, you see that that's exactly what we have here. Same numbers, but just that we have this. So if you are going to expand each, you still have to cancel that middle numbers. So just multiply this times this, and then this times this. So what do we have? 3 root 5 times 3 root 5. That's 3 times 3, 9. Root 5 times root 5, they cancel out, right? So it becomes just 5. Am I right? Minus 4 times 4, you have 16. So what do we have from here? 6 root 5 minus this. You cannot add anything here. If there was root 5 here, for instance, then you can add. But there is nothing like that. So it remains like this. Once you see that, like, don't move further. That's the end of it. Divided by what? 9 times 5, that's 45. Minus 16. So what do you have? 6 root 5 minus 8 all over what? Subtracting this, that should be 29. So this is how you solve something like this. So that's basically it. So you'll be multiplying, you'll be rationalizing, but it's just that the only thing that changes is the sign in between. That's how you solve stuff like this. So yeah, I believe I'm gonna pause it here. Yeah, I believe I'm gonna pause it here. So if you go by the videos, you should be able to understand all of this very easily. Yeah, I did cover everything about SURDS. And if there's anything you maybe want me to touch on, let me know in the comment section, and I'm definitely gonna attend to it. So today is day 12, and we're almost done. By day 14, we'll be having we'll be attending to 2 questions basically. That's what we'll be doing on day 14. So yeah, tomorrow I'm gonna try to cover calculus, and I'll also try my best to make that video about what's the name now? What I said at the beginning of the class. I'm trying to remember now. Yeah, gradients, equation of a straight line, coordinate geometry. That's the topic. So yeah, I'm gonna try to make a video covering all of that. Yeah, so for now, I will see you tomorrow, which is day 13. Try as much as possible to share this link with other people so they can benefit from it. And yes, I will see you tomorrow. Have an amazing day.